Okay, so for this lesson, we're just going to take a look at how we convert between entire and mixed radicals when we're not taking a square root. So if we have an index that's 3 or greater. So to start with, we're going to take a look at a cube root. An entire radical of the index 3 may be expressed as a mixed radical when the highest perfect cube, in this case, has been factored out of the entire radical. Now, our prime factorization method works for this as well. If I took 54 and then I split it up into 2 and 27, 3 and 9, and 3 and 3, I can see that I have 3 3's. And I have an index of 3, which means I need 3 of the same thing to move one out. So I can move one of those 3's out by taking the cube root of it, and then the 2 is still left on the inside. I could also, if I knew all of the perfect cubes, just say what is the biggest factor, or what is the factor that is a perfect cube. In this case, the only factor that's a perfect cube is actually 27. So it's the same as the cube root of 27 times the cube root of 2, and the cube root of 27 is 3, so it's just 3 and the cube root of 2. If that's true, then we could do it for all of these. We could do it using our prime factorization, so 2 and 3,000, 2 and 1,500, 2 and 750, 2 and 375, 3 and 125, 5 and 25, and finally 5 and 5. And I can see that I have a set of 3 2's, I have a set of 3 5's, and then I have a 2 and a 3 that need to remain inside. So I have a 2 on the outside now, I have a 5 on the outside, and I have that 2 and 3 on the inside, or 10 root 6. At the same rate, I could have said that the biggest cube that I could pull out of there is 1,000. And the cube root of 6, which would still give me 10, the cube root of 6. If I am taking the 5th root of 320, then I'm going to do the same process, and I have 2 and 160, 2 and 80, 2 and 40, 2 and 20, 2 and 10, and 2 and 5. And I can see that here I have 1, 2, 3, 4, 5 2's. So to take the 5th root of that, I can move one of those 2's outside. And then I'm still left with a 2 and a 5 on the inside. So I have 2 and the 5th root of 2 times 5, or 2 and the 5th root of 10. If I am doing the same thing with the cube root of negative 16, if I have a negative and an odd index, I can just move that negative out. So all I really care about is the 16. So I have 2 and 8, 2 and 4, 2 and 2. Here's my 3 2's. And I'm going to move the negative out. I'm going to move one of those 2's out, and I still have the other 2 that has to be left inside. If I'm converting mixed radicals into entire radicals, then all I'm saying is that if I have a cube root or an index of 3, and I have a number that's on the outside or a coefficient, then that's the same as 1 over 2 3 times. Which means that this would be the same as 1 over 8 times 80. And 1 over 8 times 80 is just 80 over 8, which I can simplify to the cube root of 10. So just like when we were doing the square roots, if I'm moving a number that is beside a 4th root inside, I need to multiply it in 4 times. If I'm doing one that is a cube root, I'm going to do it 3 times. And remember, with the cube roots, I can move the negative inside. If I am doing a fraction, it works the same way. And the only one I have to be careful of is if I have a even index. Then I still need to remember, just like with square roots, the negative will still have to stay on the outside for an even index. And what do I get when I simplify these? Well, the first one gives me the 4th root of 48. The second one, when I multiply the 4 times 4 times 4 times 7, gives me the cube root of negative 448. The third one, if I said this was over 1, would be the same as 800 over 125, but I'm going to reduce that and say that it's going to be 32 over 5. And for example D, I have the negative on the outside, I have the 4th root, and it's going to be 162.